All right, good morning. Okay, we're going to go ahead and start our next talk here. Since it's 10 o'clock, we want to keep on schedule. My name is Barris, and I'll be your master of ceremonies for the morning session at least. I'll go ahead and do our introductions. This will be from 10 o'clock to 10:45. I want to welcome everybody to HughesSecCon. Hopefully you guys enjoyed the keynote, for those who attend the keynote. So right now we'll have Chris Jordan, who is with Fluency, and he'll talk about how big data is changing incident response. He's currently the CEO of Fluency, and I'll let him go ahead and introduce himself and proceed with his talk. Thank you all.
Thanks. Yeah, Chris Jordan, just a quick background. So I've been doing security since 1989. I originally did work with the Army, started the Army cert in 1994 before it became public. Also moved over, took over the DoD DISA Assist, changed that into DoD cert. And studied the FAA, CCERC, JP Morgan, DuPont, NetSec, and RipTech, before eventually going on my own in 2003 doing research for the NSA and Department of Homeland Security. That company was purchased by McAfee in 2009, where I was the vice president for threat intelligence. You would know it as Artemis and the McAfee GTI. And then 3 years ago, I left McAfee to go into Fluency, which I'm really not going to go into the product of Fluency. Really, I'm going to talk about big data today and about incident response. And so that's been my focus in the last 3 years. So just to give you a good understanding of what's really important is next week, Marty McFly does come back. It's a very important date. Also important to understand that the Cubs do win the World Series in 2015, according to Marty. So a quick piece on Fluency, just to understand where I come from, is that big data infrastructure and response really has been kind of my passion from the very beginning. But big data itself has always been an issue. And I really want to cover both big data infrastructure, not just big data, and incident response, and talk about the complexity of those two working together, right? Now, a lot of people wonder about big data, and you hear it all the time. And companies say they use it, but in reality, only 25% of the companies today actually use big data, most of them for financial reasons. When it comes down to security, it's really focused on fraud. You see it a lot with your credit cards, when they deny you for shopping, let's say at Home Depot for the first time. This is what they consider big data analytics. And so even though it's a major force in today's VC economy and the capitalist economy, it's not exactly a huge force in security itself for a lot of reasons, and we're going to cover those. In fact, to try to eat through this presentation, we're going to look at the response process itself. We're going to say, hey, what is the response process? It's not so simple as just saying, hey, I respond. And then we're going to look at the big data, in particular how big data and security interact. Right now, I'm not going to be talking about the security of big data itself. That's a nice market. Big data really doesn't have much security if you know anything about how big data operates. And then finally, we're going to look at attacks. And why do we look at attacks near the end is because we have to understand what attacks look like in big data to understand how that impacts our response and what we're trying to do from a big data perspective. So why is response important? It's been a huge question in the market space. It seems that every time somebody talks about response, they like to talk about prevention. Those are two opposite things, right? If you are a person who says, I'm buying FireEye to handle incident response, you've just made a critical mistake. 1 out of every 5 companies get breached. This is IBM's number, and it was backed up by Webroot. 1 out of every 5, that means in every 5 years, the odds are you're going to get breached. Between 10,000 to 100,000 records. Now, why are records important? It's because that's how we value what a breach costs. Right now, it's about a little over $4 per record lost. Okay? So each breach, on average, if you get rid of the small breaches and you get rid of the huge breaches, the mega breaches, it's $5.6 million. That's a significant amount of money. So if you do the math, that's $1.2 million a year about. All the analysis comes back. You know what they say? They say is this, that if you are breached, your prevention devices become useless. And it's absolutely true. I've never seen a situation where a prevention device all of a sudden gets smart and starts preventing the breach all by itself. It doesn't happen. right? Once the attacker is in your infrastructure, they have multiple covert channels, and when you stop one, they just fall back to the next. So it's important to understand that you're not stopping an attack, you're stopping an infrastructure. And infrastructures are very robust. So when you start handling an incident response, you used to look at it as two different ways. And you're going to see a slide that talks about the recovery aspect and the response aspect. But there's four major steps that occur when you have to handle an incident. The first one is you have to validate it. And this is a significant amount of time. So Cisco's validation says it takes about 45 minutes to validate an event. That's significant if you consider the number of events an organization gets. It really tells you that organizations really only focus on between 10 to 20 events a day. Right? So they have to pick and choose which are those 10 or 20 because of the amount of time it takes to get through that process. That process includes what we call the scoping. So once it's been validated, we have to scope it. And scoping is something that slowly is being understood a little bit better. You probably know it as IOCs, indications of compromise. And what a scoping is what we want to do is we want to attach the attributes associated with all the events and determine whether those attributes are negative or positive, and then repivot on negative attributes and rescope. You realize that we're doing a lot of searching, and that becomes important, and that's one reason why big data is becoming a big player in incident response. And then you have two other things that are going to occur. So when I say recovery, right, that's the find, freeze, fix. Let's find the system, freeze it from the network or quarantine it, recover that machine, bring up my current asset or my repetitive asset, right? Block the flow of traffic coming in so everything's correct. Now that's the correct, and then you rebring the asset back into the infrastructure after it's rebuilt. And then finally, you track the indicators to make sure the indicators no longer appear in your infrastructure, right? So these basic four steps occur over and over again. And they don't occur sequentially like you would think about it, because you don't have one incident going on at a time. Most organizations handle multiple incidences. So if you think about how ambulances work, or actually concrete trucks are probably a better example, that they are all spread out geographically, and they have to be distributed to a different point. And this is exactly how incident response works. That you can't just pull all your resources in one incident because there's another issue going on. So from an incident management point of view, you're actually balancing all four of these steps at once. Because while one incident is in a validation, another one is in tracking, another one is being responded to. So if we were to take a look at it from left to right, what we'd see is the fact that we have information coming in. And this is the old way, really, that's slowly dying, thank God, in our industry. And that is that we have what we call our security posture. And that's all your devices and all the events they produce. Okay? And as that data comes in, we instantaneously create channels. So if you're an ArcSight user, you say, oh, I create a channel on everything I know is bad. Right? And so now I have my known bad, and then I have my false positives, or what I call my suspect data set. And what's really sad about our industry is the suspect data set to support the fact that an issue has occurred. Right? So we're actually relying on our false positives to tell us something bad has occurred. That's really a bad way of looking at the situation. Now, once I do have the incidents, you guys might have Ada Pro. I don't know how good you guys are in incident response. But when you take a look at a file, right, that's called an artifact. So we have two major aspects that we collect. The first is what we call the attributes. And that's everything I can to describe something. And then I have my artifacts. Those are the actual objects, right? The most common object that we want to collect are the executables. Enter things like NetWitness and Solera, NPulse, right? Which are run to grab out my executables. And then I'm going to evaluate those executables when I know I have an issue. The reason is because of scalability, right? I can't evaluate everything. Right? Now with big data, we're going to address that. We're going to say, yes, we can evaluate everything. But in the old days, what we would normally do is say, hey, that's an incident. Here are the files. Grab those files. Send those hashes to VirusTotal. Take those files. Send them over to the Blue Coat Ma, right? Evaluate it. Tell me what you think of these files. Drag out the IOCs from the files. And then now add those into my IDSs and my IPSs and my firewalls to block them, right? So that validation process now returns data sets, and that's what we use from the entire scope to both recover the asset and respond to the threat. And like I said, that takes time. Right? So this is the pivotal issue around response, that response is a time-driven action. And every time you do something, it's taking up your resources. So we don't like to say it, but security is a business, and time is money. And so what we want to do is shrink these 45 minutes as much as possible, right? So what we really look at is two things. One is I want to make sure I record all the things I need moving forward. Because if you know anything about computer design, we call DAGs, right? Dynamical acyclical graphs. We always want to be moving forward. We never want to turn around and look back. And by doing that, that means I want to collect everything I need when the event is occurring, from the perspective of that event. And as the information moves forward, I want to not validate something, turn around and validate it. I want to grab the validation responses and use that as a validation. So I do have a blog that talks about what we call known knowledge sets. And there's really three types. There's signatures, what we know, right? There's attributes, right? That's a signature capability. But then you move into behavioral, right? That's something you describe. And then finally, there's reputation, right? Something that's known to have occurred in the past. So Colin's in the back. And a good example is if Colin went to a bank and I saw him rob the bank, a cop came over to me, I'd say, yeah, that was Colin. Right? That's something I know. That's a signature. If I start describing Colin, that's behavioral. Okay? Finally, if I go to the police and they give me a book, I look it up, and he's in that book, that's reputation. Now what we do is we use one attribute to confirm the other. So if you think about it, signature triggers, I grab that artifact, I run it in a sandbox. The sandbox is actually providing me a second attribute validation, this time behavioral. And I use it, and I say when two of those attributes agree, I move forward. Right? So the latest pendulum swing right now is reputation data. Now we just don't want to filter out for reputation data. There's 19,000 bad IP addresses listed a day. Right? Most of those are false positives. Right? So you not just want to block IP addresses because it's a bad reputation, but you can use it for validation. Right? And you're not going to block off signatures if you don't have another attribute responding to it. So the objective here, when we take a look at it, is that we want to reduce, in our response process, people. It's not we want to get rid of people. It's just that people's time is so critical that we have to get through this, what we call this volume of data in order to start responding. And right now, the line in the sand exists near the SIM, which means that people are still reviewing almost everything. Now, as a computer geek, we always read things outside our industry. There's a really good book called 0 to 1. It's a book about innovation in the industry, in the computer industry, and they talk about the fact that computers do two things really well. They crunch data really well, and they search really well, but they don't do analytical thought really well. And so the analytical thought process, that's where the line in the sand is drawn, and right now that analytical process is at raw events. So now I'm going to switch gears. So I'm going to switch gears to big data for a second. Because to understand how big data impacts, we have to understand big data a little bit better. So the first thing you have to understand about big data is these things called data lakes. This is the way people look at big data today. What they do is they collect everything, and they store it in a location. And they like to collect what we call raw data. And these things are called data lakes. People say, oh, I put it in a Hadoop cluster. I put it in Splunk. Right? This is raw data sets, unindexed for the most part, minimally indexed. And then what's going to happen is then we're going to take data analytics against it. Data analysis. This is the three-step process for big data today. So the first one is I create a data lake. Then I basically take all my models and I say these models work. And then I'm going to use those analytics to try to predict the future off those models. And then I'm going to present them, right? There's tools like Tabula that are used to present big data. So this three-step around big data is what pretty much every big data company, if you were to hire PwC or Accenture, this is the process they're going to go. They're going to create a huge data lake. They're going to run data models against those data lakes. Say these models are substantial models that predict the future, right? And then they're going to give you a presentation of that data set so that you can work with it in an ongoing way. Watson, IBM Watson is a good example of it, right? When you get IBM Watson, they say here are the data states that work, or machine learning that work on those data sets. There's a little bit of a problem with it when it comes to security. So if you ever notice, most of these data sets are actually financial data sets, fraud and stuff like that. The issue is that fraud does have an adversary, but for the most part, data prediction doesn't. Money prediction doesn't. Sales and graphs and how people, the user itself is not trying to avoid buying things. The buyer wants to buy. So state models work really well for these people. Machine models work really well. But in the sense of computer security, you have an adversary that's going to change the way they do business. And so as you begin to predict, they modify the way they do it. So all the models that you use today become invalid. Right? If you think about it, if you were to model your data set from 5 years ago and ask yourself, would it catch stuff for today? Yes. Would it catch the most dominant attacks today? No. Right? The way the attacks work change all the time. You're going to hear a guy that says, hey, here's big data. We're going to put in this big thing. We're going to say, hey, it's obvious. It goes into the temp file. And that virus that's in the temp file then gets executed. That's so 3 years ago. It's ridiculous. Right? But that's the mentality. The mentality is that viruses always work the same way. And they don't. We have in-memory viruses today that never touch the drive. Right? So the other issue that we have is that big data loves raw data. But you, as a security person, normally don't deal with raw data. And that's cool. You just paid a lot of money for FireEye to say, hey, I think this file's bad. Why do you throw away FireEye's opinion? Why do you throw away the WebSense's opinion and say, hey, I think this is a park domain, it's kind of crap. Don't go to it. Right? You don't throw it away. These are insider perspectives. And this is where big data differs from security. We pay a lot of money for perspective. The majority of your budget is in perspective. Big data wants to throw it away. That's a huge mistake, right? And that's what we call derived data sets. The other piece is that we still need to see more, right? So this is where the next issue comes into security, is that we need more data. So there's actually something besides flow data. It's called metadata. Metadata network flows, or other people call metaflows. And what metaflows are, is it's like NetFlow, but NetFlow is designed to debug network infrastructures. Right? It absolutely sucks for security. Why? Because you don't have the URL information, you don't have the user agent, you don't have the referrer. And these are all pivotal pieces of data that occur at the application layer, what people would call layer 7, if you still existed on an OSI model, which we don't. But at the presentational layer, this is what exists. And it's critical on incident response, because we have to find out how that incident occurred. And if I don't have the referrer, I can't figure that out. Okay, so metadata is very important. And then I brought up the validation data sets, and that's another thing that's important, is that validation data sets are incredibly important to us because it saves us time. Right? I don't want to open up IDA-Pro and evaluate something and say, oh, this is a packer and these are the IP addresses in the packer. I'd rather just run it in Cuckoo and have Cuckoo tell me where the site's going. And I might only get a third of the IP addresses. That's good enough for me most of the time. Right? So the point here is the fact that validation data is another piece of data that's not raw data. So if you add these components together, the validation data, the metadata, the derived data, you start drawing a huge picture. And this huge picture is a tremendous amount of data, scary amount of data. So we have our metaflow data sets, which are not just dense vertically, they're dense horizontally. What I mean by that is there's a lot of events that are actually occurring, and these events are not small. This is not like a firewall log that just says this guy talked to this guy on this port and I blocked it using Rule 34. It's not that simple. Metadata is much larger, so it has a more horizontal growth and a more vertical growth. And then you have community data, which you don't trust everybody, but there's some whack jobs out there that actually like this stuff, and they post really good data. Malware analysis, malware traffic analysis site. If you haven't gone to that, great site if you want to practice. Right? You download a PCAP, you pull up in Wireshark, you analyze it. It's good practice. That guy actually collected all that data for you to use. And a lot of those IP addresses, because it's real data, are real threats. And they don't show up in other data sources for some reason. Reference data, GeoIP lookups, right? Your internal lookups, your DNS lookups. That's all reference data. That has to be superimposed on your data sets. We talked about validation data, we talked about reputation data, and alerts. All this data set generates a significant data volume. And this is our lead into why big data is so important. Because metadata alone is 3 times larger than the firewall logs. Then you have the firewall logs, the events, and those alert data that those SIEMs are designed to use are so small that if you were to load systems up, that's why people started using Splunk, is they started loading the firewall logs. But they can't load the metadata into it. It's just too much. They have to begin to use true big data solutions. And that's where the issue comes from, is that most people, when they think big data, they think, I can just shove it in a database. Big data is not so simple, right? If anybody started playing with it, Elasticsearch is a great full indexing. Full indexing is what you really want. You want every field to be queryable, right? That's not true for most SIEMs. It's definitely not true for Splunk, right? Splunk can consume 100,000 events per second if it's NG, but the reality, as soon as it starts to download one of those app store pieces and you start, hey, I'm going to parse this, you drop to about 3,000 events per second. Okay. So the issue around that is that you're going to be consuming around 3 to 5 just normally off a 1G line, right? So you obviously can't handle it. So now you buy multiple tiers. In fact, that's where one of the issues comes from, is you buy multiple machines in a big data infrastructure to handle the volume of data. Next thing you know, you have a system admin who all he does is maintain the machines. Okay. The other piece that I'm not really going into is that big data databases are not relational databases, period. There's no commonality between the two. And I mean that in one sense that you don't do joins. Now, I understand Bloom filters, but the reality is if I have 100,000 IP addresses and I multiply that against 1.2 billion events for that day, I have an astronomical number that cannot be loaded into the memory of this computer, right? You can't do relational joins in big data. You have to do what we call repetitive lookups. You query it, you get the response, you have to look each one up separately. So there's 19,000 bad IP addresses a day. Splunk takes 2 minutes to evaluate 100 million events. They just cut that in half, so I'll say 1 minute. That calculation means it takes 2.5 days, 2.5 days, to evaluate 1 day's worth of data. If you have 60 days trailing worth of data, right, you basically have 4.5 or 5 months worth of work to do. Right? Just off that 1 day's analysis. So obviously, there's some significant issues around non-true big data database systems. Now, if you have Elasticsearch, you can cut that time significantly, and we do pre-processing. But the issue here is that you have to understand that just because you use a big database system doesn't mean it's going to be fast. The other thing is that the interfaces that you use today are mostly relational. You say, here's my IP addresses, join them against this table. You cannot do that in big data. You have to look them up separately. The other issue is I brought up the word pivot. It's important to understand the process that goes on mentally through the system. The first one is that we have a message that comes in. Okay? And that message is what we call a key event. And we're going to tag that key event. And we're going to build our understanding around that key event. So we have all the data that comes in. And now what you're going to say is, these are all my attributes. You go through each attribute and you say, is that attribute positive, negative, or neutral? Right? It's almost like an atom. And what you're going to do is you're going to take every single negative attribute and you're going to re-pivot on the negative attribute. So if you have an event that occurs, you say, here's my referrer field, here's my user agent, right? All the different fields that you can have in a piece of metadata, you have to go through each one and say, is it positive or negative? And then rescope. And then when you rescope, you're going to get new attributes, which you go through the same process again. So you can go through 40 to 50 queries just by going through this process of tagging and rescoping. In a relational database, those queries take about 45 minutes apiece. Right? It's a significant amount of time. You can't do this technique with relational databases. And that's one reason why APTs are so successful. Because you don't look at the holistic part of the attack. You don't know all the attributes. You only focus on, this is the alert that went off, and I'm going to get rid of this alert. The second you do that, you're failing security. Right? Because the attacker is going to have an infrastructure that's going to avoid that situation. Right? So once we tag it, then we rescope it, and then we track it. So this goes back to those 4 pieces that we did before, but this is in general the process and the life cycle of incident response. Now, does everybody know what black hole is? It's such an old attack. Oh, that's not good. All right. So black hole is an exploit kit. Exploit kits are really I couldn't call it the future, it's the past of security. And these things are pretty nasty by themselves. So I'll take a step back, and I want you guys to ponder, when somebody attacks your machine, is it organized crime? And you have to ask yourself, if organized crime does most of the money laundering, isn't it organized crime that attacks your machine? The reality is this. It's just like in this room right now, there's probably more small business people than there are large business people. Right? And it's the same thing in internet crime. Almost all your original exploits occur from a person who is actually self-employed. They purchase a bulletproof hosting system. They actually hire somebody to install the exploit kit on it. They run the exploit kits. Then what they do is they buy the extra exploits if they need new ones. And then they turn around, they actually put themselves out for hire. The person who wants their machine and get their infection out there creates a binary, and it's not fear, uncertainty, doubt. It's fully undetectable, FUD. It's a different hacker term. We in marketing like to call FUD fear, uncertainty, doubt, but just Google FUD, right, fully undetectable, and you'll begin to understand that there's actually design systems out there that generate unique binaries every time they're run. Okay? And so this guy actually sells, or actually hires this person in India to go ahead and run their exploit kit with their piece of malware, their RAT, right, their remote admin tool. They infect all these boxes. He now takes these boxes. He might harvest them for information, and then when he's done, he'll sell them out to somebody else. So if you ever go to Krebs on security, and he has a discussion over these boards, in Russia, you can trade and sell infected boxes as if it's the stock market. And you just say, I need to buy a box, I need 10,000 zombies for a week, and you can rent them. Right? And you can buy them all for $1.26 for every 100 of them. Okay? And so there's a market, so when the guy's done with your system, he's already exploited everything he can out of you, and gotten the money that he thinks he can get out of your system. He then sells his boxes off as if they're empty husks. And they can be used for things like spamming. They can be used for anything the guy wants to do. He might reharvest it as we call redirect systems and TDSs, traffic distribution systems. The value of your box is all determined by how closely you sit to the internet, how well you do route. So anyways, so an exploit kit is a little nasty piece. And what exploit kits allow is it allows this person in India to actually know nothing about hacking. Right? All they have to do is download an exploit kit, install it, whether it's Orange, whether it's Neutron, whether it's Black Hole. Now Black Hole, the guy was busted for Black Hole. Thank God. Right? Black Hole was a nuisance. But it hasn't been replaced. There's tons of new guys out there that actually generate a much better exploit kit than Black Hole. Almost all of them are written on PHP, right, with a MySQL background. Okay? And what these sites do is they'll basically seed a victim site. So they go out, they take, let's say, the latest WordPress, and they just slam it against the entire internet. They get 4,000 or 5,000 machines, and they put a brand new redirect iframe into that machine, and they say, redirect to my Black Hole server. It'll be a 1 pixel by 1 pixel or 2 pixel by 2 pixels. They change it only to avoid IDS, IPS. But it'll be a small little window that's invisible to you and hidden. And then that little window will say, hey, I need this jar file, I need this PDF, I need this. And it will exploit a number of different exploits that will be downloaded on the landing page. Okay? Each exploit is then run, and if successful, it downloads a file. And when it downloads that file, it will have an extension, like E=4, right? And you think, well, what's that extension for? It's really simple. The hackers actually use it to determine which exploits are working. Okay? So they know when they attack a system, these are the exploits that work for this. Right? They don't have to actually, by the way, seed the infrastructure. Remember, they can buy machines. So what they can do is they can say, listen, I want to buy 10,000 Windows 8 systems. And they go and they buy 10,000 Windows 8 systems and they redirect them to their exploit server. And they repwn them. Because now they don't have to pay the other guy to rent them. Right? The other thing they can do is they can buy advertisement. So a lot of these TDS guys actually just sell it as advertisement space. And then you insert a malicious ad into the pop-up. Malvertisement. Right? So there's a lot of capability here where now the machine gets done, it's now got its rat on it, and now it's owned by somebody. And this is exploit kits, right? And it's not one guy running it. This is an entire industry of small businesses working together. And when they're done, they then push this on, right? One of the cooler exploit kits out there that people know is Game Over Zeus. That's an EK, right? So Game Over is the variant, but it actually, the Zeus used to use the black hole as its EK to install that rat, right? It doesn't make a difference which EK I use, Game Over is delivered. And how does it look from the defense side point of view? So here's a good example. If you can see it, these yellow markers are the only session that would alert from this particular attack. This is a data set from a guy named Chris Kaspersky, who's a fairly well-known hacker, and he's good enough to lend me some of his PCAPs. And this one here, even though we have some decent triggers to say, oh, it downloaded and it was against policy, I think this might be bad, but the little red marker there is the shockwave file. The shockwave file shows up as being malicious, right? So if you're not evaluating files, you're not evaluating the artifact, you really don't have anything to pivot to validate it. But remember before, I said there's three things, first, second, and third degree attribute. I've got two here. I've got signatures triggering, and now I've got a behavioral alert. So I know this is a valid event. And I can pivot and pull this up, right? And walking through this because it's important to understand that now this is where scoping comes into play, right? So I've now found one issue, and that was a shockwave file being downloaded. But I just got done describing an exploit kit, right? So what are the components of an exploit kit? I need to know my compromised box, right? I need that through the referral field. I need to know my TDS, my traffic distribution system. I need to mark those suckers up. When I get my download, I'm going to be able to find the landing page. I need to mark that. I need to find out not only what pieces of the exploit worked, I need to find out all the ones that didn't. Right? Why? It's because I need to understand this attack completely. And that's just the attack. Then I have my rat. A completely different animal. Literally. It is on your box. It's not even owned by the guy who just exploited your machine. It's owned by a completely different organization. Right? And now you have the situation of saying, where's this rat going? How's it communicating? Does it use a dynamic a DNS, what was that, DGAs? I can't even think what they stand for anymore. But it's a domain-generated algorithm, right? What does that mean? It means that every time, every couple hours, the domain name changes, right? And if they're using a fast flux, the IP address is changing, right? These are pretty nasty type of things. You have to know all the pieces. You have to mark every single one of them. You have to say, this is my command and control of the rat. This is what it looks like. This is a post to a root off of WordPress. That's bad, right? All these aspects of the attack have to be marked because when you start shutting down the infrastructure, the attacker is going to be changing their position. So to kind of hit what APTs kind of look like and why prevention doesn't help us with APTs, it has to do with the fact that if you walk through it, you're dealing with 4 to 16 exploits per kit, right? A lot of kits can actually download new ones on the fly. 0 days are not needed, okay? The attacker is measuring which ones are successful against your organization. He can even buy IP machines and an address space targeted for your domain. I can go to a TDS and say, give me everybody who works for IBM. I can get all the IBM systems. And I can start just exploiting them. I can say, give me I know the referral tags, the system user agents. I can actually determine which are the operating systems, right? The attacker checks it. This is really cool. Check my IP. There's a bunch of different products out there for hackers, right? There's actually a couple versions of VirusTotal that they can upload their virus and they get a message when any of the major AV vendors know about them. Why? So they can now change and recompile their FUD. It takes about 5 minutes to recompile a FUD. So they just change their FUD and then resend it up in their exploit kit. That's why their viruses aren't seen until 24 hours or 48 hours later, because they're not using them anymore. You're looking at the old file. They just repacked it. Okay? They do the same thing with reputation. They check their reputational IP addresses and they take their domain host name checks. So there are any hardcore security guys that have been doing incident response out there? Sweet. So you probably have noticed that the big trick nowadays is Cloudflare. They love to use Cloudflare. You cannot block Cloudflare. If you block Cloudflare, you block Akamai. You block 25% of the internet. So there are a lot of these hackers are right now using Cloudflare because those IP addresses are never going to be blocked. Right? You have to block by the host name. This whole concept of blocking by the IP or blocking by the port, it works when the attackers are using it. And this is what incident response is all about, is what is my attacker using in order to get in my infrastructure? Right? So the attacker is constantly changing, constantly looking at how their attack works, what's being seen, and then the very reason why APTs work. They change their infrastructure to avoid being detected. When you start blocking a DNS or you start seeing stuff going to DNS sync, the attacker gets rid of it. When the attacker runs a rat, the rat will have a DLL that calls back, right? And actually allows the person to tunnel. And when it calls back, by the way, it sends the internal information of that system. So when you run cuckoo, it will actually let the attacker know you're running cuckoo. And you will tell the attacker you're running FireEye. And the attacker will know your infrastructure, and they'll modify their attack, right? Over time, you will lose if you don't track those things that were all the attributes of the attack. Because what the hacker is not going to do is he's not going to get rid of his bulletproof hosting. He's not going to change his name servers, right? He's not going to change everything all at once. It took them months. Some of these people years to set up this infrastructure. They're not going to change the entire infrastructure at once. The attacker changes a piece at a time. So when you have an APT, you need to redetect every time the piece changes. And if you go back to that one piece, and I did it so many slides ago, I think it's important though. This one. Track. The reason why we're tracking the events is to see what pieces we know about so we can rescope to find the brand new pieces of the APT. And APTs is not something, it's not really advanced. It's just persistent. There's nothing advanced about APT. Out of those 16 exploits, there might be one that's new within the last week or two. Most of the attacks are really well known, right? All the attacker's doing is getting a foothold and growing, right? They're stealing the hash. They're taking your certificates. The first thing any decent attacker's got to do is he's got to take your mail system, right? He's got to take your AAA. He's got to take your LDAP. Once I have those three, I got your network. I was helping out the FDA one time, and we had a conference room, and it snowed. We had that snowmageddon like 4 years ago. Now 5, dated myself. And we're in the meeting, and this one guy, he shows up, and he had emailed everybody before saying he wasn't going to be able to make the meeting. It was a review of a drug. It was a kind of a very secret meeting. And everybody got a text saying, hey, I couldn't make the meeting because of the snow. Can you send me the notes? And the guy's in the room with us. Okay? The attackers had the mail system at the FDA. Right? It's not unusual. Right? So I brought up Marty McFly. I got to bring up this one. One of the Sharknado of my industry. The movie Hackers. Angelina Jolie and Pleather. Okay? What's beautiful about this show, actually, is that it's actually pretty accurate in one sense. The attackers are creative. They dumpster dive. They do all these crazy things. That's actually how things work, right? If you ever see the interview with the guy who made this, he'll tell you that they showed the movie and actually showed the people doing the keystrokes, and the audience hated it. And when they showed graphics, they loved it. So all the graphics in there, completely done. The way they dress, they love to make fun of the way they dress. Actually, they actually went to 2100 meetings. 2100? 2600. 2600 meetings. And they actually went there and they found out most of these guys buy their stuff at thrift stores. So the director goes to thrift stores and he buys all the people's clothes except Angelina Jolie's, who they buy at Nordstrom's or some high-end piece. So anyways, I only bring it up because it's the 20th anniversary, September 15th, 20 years ago. So, and you get the new Blu-ray. I don't get any money for that. All right. So to kind of wrap it up, because I think it's kind of important that I've talked about a lot of different things. It's important to understand that the issue around big data is because we do need to collect this data. The more data you have, the better off you are. The problem is organizing your data and getting to your data quickly. Right? That's infrastructure. right? The other issue is integration. I'll cover that in a second. One of the more important pieces, and I used to do this every time I taught at McAfee, I'd do a room and I'd say, just don't fire your analytics people, right? Don't fire your incident response people. There's not a single machine that is going to replace a human in your organization. Humans are your best analytical thinkers. They'll outthink a machine learning system. The work that we did with the NSA and DHS, we showed that a computer needs 12 variances, not 12 packets, but 12 variances of an attack to learn it. A human can do it with three. So there's a huge difference between what a human can do and what a computer can do. And there's not many variations of the attack in your organization. You can't do it with machine learning. That's why this whole idea of cloud, where we send everything up in the cloud and we pull everything down, we're using other exploited machines so that you don't get exploited. That's the beauty of the system, right? Unfortunately, every once in a while, you might be victim number one. And then finally, APTs exist not because they're new, right? They exist because you're not responding completely to the attack. It's that simple. And I'll cover that one with the very last slide. So, collecting, just to give you, to rehash, because I talk about collecting information, there's a huge difference between where we stand in the industry today and anybody who's ever done system integrations. And it's the difference between listening to a radio and being in a classroom, right? Nobody will ever sit there and think that sitting down and watching YouTube videos of your teacher is going to make you a better student. You have a teacher to ask a question to get a response. That's integration. Right? Right now, the entire industry is based upon collecting information without ever asking a question to the device, even though most of these devices have APIs that allow you to ask a question. The other one is the fact that even though we keep on talking about these huge number of alarms, FAA had 1.2 million events a day. Right? The reality, the number of critical events were much smaller. Right? That we have to grab the critical events to include the ability of things like validation files. FireEye does it in a stovepipe manner. Really, this should be done across the entire infrastructure. You should be able to have the capability of tracking whether you shot 256s and indexing your files in your system, indexing them going out. We're working with Samsung. What they're doing is indexing them leaving. They're looking for DLP. But the ability to know every single file is in your grasp with big data. So lastly, I'll beat up on Target. The reason why Target's a really good poster child is the fact that actually Target did know they were attacked. And even though they were running so-called FireEye as a analysis at the time, the reality was that their semantic that they were running also was alerting. They had tons of alerts. The actual response by FireEye was reboot the system. They knew the POS was infected. It would actually freeze up, and the answer was reboot it. Right? FireEye was going to wait till January, after the Christmas season, to fix the issue. This is a response issue. Right? Response is really our biggest problem in industry. We love, as they say, the world of shiny new things. We want a new thing that detects and prevents. The reality is there's not a single machine I can buy that's smarter than anybody in this room. The objective is to reorganize our infrastructures, right, to leverage our people. All right. So I guess I have like a couple minutes. I normally don't take questions. I do have a blog. I just changed sites, so it's really quiet on my blog right now. Not the posting, just the people going to it. So, all right. Thank you.